Sharath. Oh, hi. How are you doing?
Good, thank you.
Welcome, welcome on stage. Sharath is joining us from Australia, if I'm not mistaken,
That's right.
and he's with RMIT University, and he'll be telling us about stretchable and flexible electronics reshaped for industry-driven aged care technologies. So you have 20 minutes. I'll give you a heads up if I feel like you're about to, massively overrun, and then we go into Q&A. So good luck to you.
Thank you very much. Thank you for the opportunity to present at this session. I'll be talking about how we've taken electronics at the lab scale, worked with industry, and made it into a few products very specifically focused on aged care applications. There's always a curiosity about what RMIT stands for. So it's Royal Melbourne Institute of Technology. So we are based in Melbourne, Australia. A bit of background in terms of what we do. The I run a research team of about 45 people based in a university setting. It's a mix of material scientists and electronics engineers working at the interface of biology, medicine, and chemistry. And so we make a whole range of devices which cover neuromorphic technologies, high speed electronics, photonics, and wearable devices. So, what I'm talking about today focuses mainly in the wearable device context. Most of our work are done in semiconductor clean rooms. So the facility we use is called the Micro Nano Research Facility. If anyone's interested, I'm happy to explain about that separately and ways to work together. But it's a 1250 square meter, approximately 10,000 square feet, class 100 and class 1000 clean room spaces. And it allows us to go from an idea or a concept all the way to early stage prototypes. And so how we work projects in this space is often it's industry driven. So our collaborators come to us with challenges or questions, and our team brings together an entire solution for them. We work with manufacturers so that whatever we design for them is compatible with manufacturing. We bring in business innovation experts and user centric design. So as I talk through a couple of examples, you'll see some cases of how this is actually put into practice. So this is a slide we usually use when talking about wearables. Obviously, the session is on wearable technology, electronic textiles, and skin patches. We like to always refer to this as wearables might be a new buzzword, but it's existed for 40, 50 years now in very different forms. And the main difference we are trying to make is take the hard form factor of wearables away, make it much more flexible, skin compatible, soft, pliable, so that in a way people do not even realize it's around them and it's very comfortable to use. So when we started the work in this space, our motivation was pretty simple. We wanted to make electronics which are unbreakable and which will actually self heal. So they can stretch, flex, they may stop working beyond a point but would recover. You would have come across a lot of flexible and stretchable electronics technologies, devices on silicone, for example. A lot of our innovation was around combining high temperature processed oxides, so oxide thin film crystals with polymers. And obviously, most of these oxides with functionality are processed at 600 degrees and above. The polymers would burn at that temperature. And so we had ways to actually combine and build them. And we made a whole range of fully transparent, stretchable electronic devices. Uh, so while that was the fundamental work, as we were talking about these devices, working with different use case users and industry partners on wearable patches, we've actually set a very different problem by an industry partner. And that's the first case study I'm going to talk about. It resulted in a commercial product called REMI. So REM as in REM sleep, and it's about intelligent sleep. Uh, the proposition here is what would be the bedroom of the future, and how will that actually give us information about our sleep patterns, improve cognition through better sleep. But as the company looked into that space, they realized most people do not value sleep, they do not understand the value of sleep, and so that's probably